My name is Celine, the voice behind the videos that you have been watching. I know you probably have been wondering why is the face behind the voice. Well, today you get to see the face. If you're new to my channel, welcome again. So I'm gonna do a little introduction because I noticed that I have never done one. So like I said, my name is Celine. I am passionate about software engineering, and that is the main reason why I chose to start this channel. Originally, I intended to use this as a platform for me to learn, which it really has helped me. But then again, along the way, I noticed that I was helping other people learn as well, and that means a lot to me, and that is why I'm quite excited to do more videos. But also, I really want to use this channel to showcase my journey in technology as a woman in tech, and I look forward to growth and learning with you guys. So today we're gonna look at another question and answer the question. Thank you. So here's the question. We have given an integer n. We're supposed to return true if it is a part of 2, otherwise return false. And then we're given these examples here. For example, 1 returns true because 2 raised to power 0 is 1. But we also look at 16 returns true as well because 16 is a power of 2. When you look at here, 2 raised to power 4 is 16. But then again, 3 and 5 are not powers of 2, and that is why it returns a false. So we're going to look at two different ways of approaching this problem, and the first and most straightforward solution here would be we'd go ahead and check whether the modulus of this number n is equals to 0 or not, because we know that if a number is divisible by 2, most certainly it is a power of 2. Okay, so that's the first thing you're going to go ahead and do, and then while checking that, we're going to go ahead and keep dividing n by 2 until we get to a point whereby n is equals to 1. Okay, if n is equals to 1, that means that it is a power of 2, and otherwise it's not a power of 2. So the first thing we're going to do when writing this in code is that we're going to have a base check. So in this case, our number should not be 0, and it should also not be less than 0. So we're going to go ahead and see if n is less than or equals to 0. We're going to go ahead and return a false. Okay, and then after doing that base check, what you're going to do is that we're going to go ahead and do this, because we're going to go ahead and keep dividing while the modulus of n is equals to 0. Okay, so while this is equals to 0, we're going to go ahead and keep dividing n by 2 until we get to a point whereby we can no longer divide it. So we'll go ahead and check whether n is equals to 1. So what this function down here does is that it returns true if n is equals to 1, otherwise returns false. So if n here will be equals to 1, that would mean that our number is a power of 2. Otherwise, it would mean that our number is not a power of 2. So we're going to go ahead and check it. And yes, it works. If we go ahead and submit this, as you can see, our solution has been accepted. But then again, we want to make our solution more optimal, because when you look at this program here, the time complexity is O log n and the space complexity is On. We can make our solution more optimal by making the space complexity O1 as well as the time complexity. So that is what we're going to look at in our second solution. So this is the expression that we are going to use for our second solution, and I'm going to show you basically what it means. So what it means is that we're going to clear the right most side of the numbers in binary form. So first, for this problem, you need to know how to represent numbers in the binary form. So for example, we have 1, which is 0 0 0 1. We have 2 0 0 1 0, 3 0 0 1 1. We have 4, which is 0 1 0 0. That is 8. That is 1 0 0 0. There is 16. That is 1 0 0 0 0. We have 5. that is 0, 1, 0, 1. So basically, I want you to notice something. When you look at these numbers, you notice that numbers which are powers of 2 only have one digit, that is 1. So if you look at this, we also have 2, we also have 4, we also have 8, we also have 16. But if you look at the numbers that are not powers of 2, you will notice that they have more than one digit, that is 1, okay? Yeah. So that is something that you need to remember because it is a characteristic of numbers that are powers of 2. So like I said, back to this expression here, and what it means is that we're going to take the rightmost one and change it to 0 and see what we get afterwards. So if we change the rightmost one to 0, we'll get 0, 0, 0. Same thing happens to this one. Same thing happens to 0, 0, 1, 0. We also have 0, 0, 0, 0. We'll have 0, 0, 0, 0. Same thing, 0, 0, 0, 0, and then we'll have 0, 1, 0, 0, okay? I want you to notice something. For numbers that are powers of 2, we are getting this, which is a representative of 0. But for numbers that are not powers of 2, like for example 3, we are not getting 0. So basically this expression here is used to determine whether a number is a power of 2, in that if it results to a 0, that means it's a power of 2, as represented here. Otherwise, that means it's not a power of 2. Okay, so I hope you've gotten the binary representation here and basically the explanation behind that. We're going to go ahead and look at the code solution. We're going to go ahead and do the base checks. This is something that is very important, and you need to always remember to do these checks whenever you're presented with a question or a problem. So this shows that you're someone who is a good problem solver, in that you'll always think about the different scenarios and different cases to help you solve your problem. Okay, so I'm going to go ahead and do if n is less than or equals to 0, we're going to return a false. Otherwise, what we'll do is that we're going to return an n and n minus 1 equals to 0. Okay, so basically what this function down here means that it's going to return a true if it's equals to 0, otherwise it will return a false. And as explained, if it's equals to 0, that means that it is a power of 2, and otherwise it is not a power of 2. So this program here has a space and time complexity of 0.1, which makes it more optimal than the previous solution that we just solved. So I'm going to go ahead and run it, and it is accepted. We'll go ahead and submit it. And yes, as you can see, it's faster than the previous solution, which makes it more optimal. And that is it. And that is how to approach this problem in those two different ways. I hope you've learned something, and looking forward to seeing you in the next problem. Thank you.